Hi, my name is Praneeth and welcome to my channel Everyday Space. In today's video, you're going to see me launching a satellite to geostationary orbit using the GSLV Mark III rocket that ISRO has. All this simulation is going to be done in the KSP or Kerbal space program. It is one of the best simulators for rocket launches and deploying the satellites. So let's get started. So as you can see here, this is the GSLV Mark III rocket that we are going to use today to launch our satellite into geostationary or geosynchronous orbit. So now let's take a look in detail about the different parts that make up this amazing rocket. So now let's take a look at the first stage of the rocket. The first stage of the rocket are these S200 solid rocket boosters. These two solid rocket boosters are the main solid rocket boosters and will ignite at the start of the launch. So after these two, now let's look at the first stage of the rocket. So as you can see here, there's two Vikas engines at the bottom. These are Vikas derivative engines. And as you can see here, there are two of these at the bottom of the rocket. This entire thing is the first stage, as you can see here. This center core is the first stage of the rocket. Now let's take a look at the second stage or the third stage of the rocket. This is the CE-20 upper stage engine. This is a cryogenic engine and will boost the satellite into its final orbit. This is the liquid fuel tank that will provide the fuel for the CE-20 engine. So now let's take a look at the satellite that we're sending to space today. This is the satellite. I will take this out of the GSLV and show it in more detail. So as you can see here, this is our satellite that we're going to be sending to geostationary orbit. Let's take a look at the different parts that make up this amazing satellite. First, we have this Dawn electrical propulsion engine, which uses xenon gas from this container and boosts it into its final resting orbit. This is a very small powered engine, but is very useful for long drawn out orbital corrections. Now let's take a look at what actually powers our satellite. These are the two solar arrays or solar panels that power the spacecraft. These two solar panels would send their electric charge to these two rechargeable batteries. So they can retract and deploy when needed. So let's take a look at how they'll actually communicate down to Earth. We have two 100G antennas here for whichever side the Earth is facing on. These can transmit any data from this satellite. These are also powered by the two rechargeable batteries and the solar panels. So this is a scanner that can scan the Earth and send data back to Earth. This is used for weather mapping and GPS. We have two science experiments here. This is a surface scanning module and this is a barometer to see how the conditions are in space. This is the satellite that we will be sending to geostationary orbit. So now let's take a look at the launch profile of this GSLV Mark III rocket with the satellite that I showed you earlier. So as you can see, this is the GSLV Mark III rocket standing on the launch pad. Now it launched liftoff. The two S200 solid rocket boosters are the first to ignite and will take the rocket to an approximate height of around 100 kilometers. So as you can see, the heating has started because it is now exiting the atmosphere. This is where the rocket will experience the most pressure because of the extreme forces. As you can see there, The core 2 Vickers engines have just ignited and are boosting the rocket even further, along with the S-200 solid rocket boosters. Now the heating is getting really intense as we are now exiting the upper atmosphere of Earth. After this, there will be no more atmosphere and the rocket is free to go. Now the heat is slowly cooling and the S-200 solid rocket boosters have run out of fuel. And now you can see them separating away from the core stage of the rocket. Now it's just the second stage and the third stage to boost the satellite into geostationary orbit. So as you can see, now we're about to deploy the fairings on this spacecraft. The fairings will then reveal the satellite inside. So we're still boosting the rocket even higher into the atmosphere. For this to be in geostationary orbit. So now the first engine ran out of fuel and is now cutting off from the second stage of the rocket. As you can see there, it is slowly going to separate away from the rocket. So as you can see, the second stage is continuing to go on its orbit and is going to go to the apex, or the highest point of its orbit, to raise the lowest point to successfully be in orbit. So we're going to turn on the second stage of the rocket shortly, the third stage of the rocket. The CE-20 is going to take the satellite into its final orbit. So as you can see, we're just orienting the rocket to burn later on. So our goal is to basically make this in orbit. So as you can see there, the CE-20 engine has now just ignited and is boosting the orbit even higher. As you can see, the orbit is slowly raising, and now it is officially in orbit, but we need to raise it even more to be in geostationary orbit of 2,868 meters. So we're around approximately in that area of around 3 million meters, and we're just going to do final corrections before we deploy the satellite. So we're still raising it to around 3 million meters. Okay, so now you see we're still trying to get as close as we can. So the satellite's engine doesn't have to do that much. There's going to be numerous burns after this. So there, I skipped forward the burns, and now we're about to see the third stage of the rocket separate from the geostationary satellite, as you can see here. So this is eventually going to deorbit itself and burn up in the atmosphere. Now officially, this satellite is close to geostationary orbit. So as you can see, the batteries have almost run out of electric charge, so we have to recharge them. This is why I am deploying the 2 solar panels on this satellite. You can see the battery slowly charging up as the solar panels provide energy. So I've deployed both the solar panels, and the 2 batteries are slowly recharging now. So now we need to make sure the satellite does final tiny orbital corrections to be in a perfect geostationary orbit. So as I told you earlier, this satellite actually has an onboard engine that is not very powerful, but it is perfect for tiny orbital corrections. You might not see it there, but the engine is actually ignited. So the apex is exactly at 2,868,000 meters. So the periapsis should also be that. So there is no lowest or highest point. So we are very close to the apices, so now we can raise the periapsis. So as you can see, we need to raise it 6,000 more meters to make it into a perfect geostationary orbit. So yes, we have turned on the engine, and it looks like both of them are exactly at 2,868,000 meters. So now let's take a closer look at the satellite itself. So as you can see there, I deployed the survey scanner, which will scan the Earth. Now we're going to deploy the two antennas that I discussed earlier about. They will unfold and then they can transmit data back to Earth. So you can see the two of them just deployed right there. So those are the rechargeable batteries that I showed you earlier that hold electric charge to keep them. And those are the gigantic solar panels that I deployed earlier to charge it. And at the bottom you can see the engine. And we have two science experiments on board. One is another surface scanner and one is a barometer. So as you can read there, it says literally that we are in a vacuum. So now let's try and use the antenna to transmit data back to Earth. And now we have successfully transmitted back to Earth using the antenna. So this is the satellite that I showed you earlier, now fully deployed and functional in space, in geostationary orbit. So now let's see how it's going to go. It's just going to follow that blue line over and over again. Like that. It's going to keep on orbiting the Earth. And the Earth is never going to move because it is in a geostationary orbit. It moves exactly along with Earth. So yes, as you can see there, we are now transmitting back to the site we actually launched at because we are very close to it. Yes, that's where we launched from. So the satellite will keep on going until its lifespan is over, which it will then deorbit at. So thanks for watching, and if you want to see more of my videos, please subscribe and like. I spent a lot of time making this video, and if you want to see more of my other KSP videos, be sure to check them out in the comments for any future ones. Be sure to check out my other videos when I explain the PSLV and GSLV rockets, also other ISRO rockets. In my next video, I'm going to be doing another simulation in KSP about the Gaganyaan mission that ISRO is planning to do when they launch the first humans into space. So thanks for watching.